Hi students, in this lecture we will discuss about the topic matrices and calculus. First one is we will discuss about the types of what is meant by matrix and types of the matrix and the eigenvalues and eigenvectors, non-symmetric matrices with repeated eigenvalues and also non-symmetric matrices with non-repeated eigenvalues. What is meant by matrix? A rectangular arrangement of numbers in rows and columns is called an matrix. It is denoted by square bracket or open bracket. The order of the matrix is denoted by the number of its rows and columns. Row matrix. What is meant by row matrix means a matrix having a single row is called a row matrix. For example, 1 3 5 minus 7. It consists of a only single row and 4 columns. Next one is column matrix. A matrix having a single column is called a column matrix. For example, 1 2 minus 3. It contains a 3 rows and only single column. Square matrix. A matrix having an equal number of rows and columns is called a square matrix. For example, 1 minus 2 3 5. It has a only equal number of rows and columns for 2 by 2 matrix. Next one is null or zero matrix. In a matrix, if all the elements are 0, then that matrix is said to be a null matrix or zero matrix. It is denoted by O. Next one is diagonal matrix. Every square matrix is said to be a diagonal matrix if all the entries are 0 except the diagonal elements. For example, 2 0 0 0 minus 1 0 0 0 3. Here this matrix is a 3 by 3 matrix. Diagonal elements are 2 minus 1 5 and all other elements are 0. Scalar matrix. In a diagonal matrix is said to be a scalar matrix if its diagonal elements are the same, then that matrix is said to be a scalar matrix. Next one is unit or identity matrix. In a diagonal matrix, all the diagonal elements are 1 is called the unit matrix or identity matrix. It is denoted by capital I. Next one is upper triangular matrix. A square matrix is said to be an upper triangular matrix if its all the below leading elements are 0, other elements having. Next one is lower triangular matrix. A square matrix in which all the elements above the main diagonal elements are 0 is called the lower triangular matrix. Next one is transpose of a matrix. Interchanging rows and columns is called a transpose of a matrix. It is denoted by A dash or A transpose. Symmetric matrix. A square matrix is said to be a symmetric matrix if A equal to A transpose. Suppose non-symmetric matrix means a square matrix is said to be a non-symmetric matrix if A not equal to A transpose. Next one is skew-symmetric matrix. A square matrix is said to be a skew-symmetric matrix if A equal to minus A transpose. Next one is singular matrix. A square matrix is said to be a singular matrix if determinant of A equal to 0. Suppose inverse of the matrix exists if A determinant of A not equal to 0. Power of a matrix. A square matrix is said to be an idempotent if A square equal to A. Periodic matrix if A power k plus 1 equal to A. Nilpotent matrix if A power k equal to 0. Involutory matrix if A square equal to I. What is meant by orthogonal matrix? A square matrix is said to be an orthogonal matrix if A transpose equal to A transpose A equal to identity matrix or A inverse equal to A inverse A equal to identity matrix. If a matrix A is an orthogonal matrix if A transpose equal to A inverse. Next one is characteristic equation. The equation determinant of A minus lambda I equal to 0 is said to be a characteristic equation or characteristic polynomial. For simple way, 2 by 2 matrix. Characteristic equation for 2 by 2 matrix. Lambda square minus S1 lambda plus S2 equal to 0. Here S1 is the sum of the main diagonal elements or leading diagonal elements or trace of A. S2 is the determinant of A. For 3 by 3 matrix, the characteristic equation for 3 by 3 matrix is lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Here S1 is the sum of the main diagonal elements or trace of A. S2 is the sum of the minor of the main diagonal elements. S3 equal to determinant of A. Next one is we will discuss about the topic eigenvalues. The characteristic roots of this characteristic equation is called the eigenvalues of A. Next one is eigenvector. Let A be a square matrix such that Ax equal to lambda x, then the vector x is called the eigenvector of A corresponding to the eigenvalue lambda. Next we will discuss about the problems based on non-symmetric matrices with non-repeated eigenvalues. Find the eigenvalues and eigenvectors of the matrix A equal to 11 minus 4 minus 7, 7 minus 2 minus 5, 10 minus 4 minus 6. Here matrix A, the matrix is non-symmetric because A not equal to A transpose. Next one is, first we have to find the characteristic equation for this 3 by 3 matrix. The characteristic equation is lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. S1 equal to sum of the main diagonal elements, that is 11 minus 2 minus 6, that is equal to 3. Next one is S2. S2 equal to sum of the minor of the main diagonal elements. First diagonal element is 11. Minor of this 11 is determinant of minus 2, minus 5, minus 4, minus 6 plus next diagonal element is minus 2. The minor element of minus 2 is 11 minus 7, 10 minus 6. Next diagonal element is minus 6. The minor of minus 6 is 11 minus 4, 7 minus 2. Cross multiply 2 minus 2 and minus 6, minus into minus plus 2 into 6 equal to 12, minus symbol. Next one is minus 5 into minus 4, that is equal to 20, plus 11 into minus 6 is minus 66, 10 into minus 7 is minus 70, that is plus 70, plus minus 22 plus 28, that value is 2. Next one is S3 equal to determinant of A. 11 into minus 2 minus 5 minus 4 minus 6 plus 4 into determinant of 7 minus 4, 10 minus 6 minus 7 into determinant of 7 minus 2, 10 minus 4. This determinant value is 0. Therefore, here substituting S1, S2, S3 in this characteristic equation, that is lambda cube minus 3 lambda square plus 2 lambda equal to 0. Take lambda common outside, that is lambda into lambda square minus 3 lambda plus 2 equal to 0, that is lambda equal to 0. Lambda square minus 3 lambda plus 2 equal to 0. The factor of lambda square minus 3 lambda plus 2 equal to 0. The factor of lambda square minus 3 lambda plus 2 is lambda minus 1 into lambda minus 2. Therefore, the eigenvalues are lambda equal to 0 and lambda equal to 1 and lambda equal to 2. Next one, we have to find the eigenvectors of this A matrix. Determinant of A minus lambda I equal to 0, lambda I into x equal to 0. Determinant of A minus lambda I is 11 minus lambda minus 4 minus 7, 7 minus 2 minus lambda minus 5, 10 minus 4 minus 6 minus lambda into x1, x2, x3 equal to 0. First our eigenvalue is lambda equal to 0. Lambda equal to 0, substituting in the above matrix, we will get 11 minus 4 minus 7, 7 minus 2 minus 5, 10 minus 4 minus 6. Cross multiplying, we will get the characteristic equation, that we will get the eigenvectors are 1, 1, 1. This is the eigenvector corresponding to lambda equal to 0. Next one is put lambda equal to 1 in the eigenvectors equations. 11 minus 1, that is equal to 10 minus 4 minus 7, 7 minus 3 minus 5, 10 minus 4 minus 7. We will get the eigenvectors x2 equal to 1 minus 1, 2. This is the eigenvector for corresponding to lambda equal to 1. Next, substituting lambda equal to 2 in the above equations, we will get the third eigenvector, that is 2, 1, 2. This is the third eigenvector corresponding to lambda equal to 2. Next one is, we will discuss about the topic non-symmetric matrices with repeated eigenvalues. First one, find all the eigenvalues and eigenvectors of this matrix. First one is, we have to find the characteristic equation lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. S1 equal to sum of the main diagonal elements. S2 equal to the sum of the minor of the main diagonal elements, and S3 equal to determinant of A. Here substituting S1, S2, S3 in this equation, characteristic equation, we get lambda cube plus lambda square minus 12 21 lambda minus 45 equal to 0. Here this is the third order equations. Substituting, put lambda equal to 1. This equation should not be equal to 0, and substituting lambda equal to minus 1 should not be not equal to 0. Here like this, lambda equal to minus 3, then this characteristic equation should be 0. Therefore minus 3 is the root of these equations. Therefore substituting L division method, 1 minus 21 minus 45 minus 45, we will get the eigenvalues are 5 minus 3 minus 3. Here minus 3 are the repeated eigenvalues. So we have to find the eigenvectors. The eigenvectors a minus lambda I into x equal to 0, a minus 2 minus lambda 2 minus 3, 2 1 minus lambda minus 6 minus 1 minus 2 minus lambda x1 x2 x3. Substituting, put lambda equal to 5 in the above equation, we will get the eigenvectors 1 2 minus 1. Here minus 3 are the repeated eigenvalues. Substituting lambda equal to minus 3 means all the equations are similar. So we have to find the eigenvectors in cross section method, means we will get the eigenvectors all are 0, but eigenvectors all are should not be equal to 0. So we have to find the eigenvectors. Consider any one of these equations. Substituting x1 equal to 0 in this equation, 2x2 equal to 3x3, x2 by 3 equal to x2 by 2. Here this eigenvector is 0 3 2, and also substituting x2 equal to 0 in the above equations, we will get x1 minus 3x3 equal to 0, that is x1 equal to 3x3, x1 by 3 equal to x3 by 1. Our third eigenvector is 3 0 1. Thank you.